Hey everyone, today we're going to be looking at 7B Part 2. Sorry for the rough start there. Remember, you can pause this video anytime and or click that back button if you need to go back 10 seconds and because you missed something. I'm going to skip over this today because this is just what we did last time, and I think you should be able to just go back and look at your notes and the video there. So today we're going to be looking at domain, range, maximums, minimums, and then intervals on increasing and decreasing and behavior. So there's a lot going on today. We're going to do it like we did last time where we go and we look at, apologize for that. We're going to do it like we did last time where we do the two things, we go find those two things, we come back, we look at two more things, and we keep going back and forth. So domain and range is one of those topics in math that I think a lot of students overthink. There's a lot of things in math that I go, okay, yeah, that's kind of difficult. Things like quadratic formula, factoring the first couple times you do it. Okay, but this is one of those things I think just students overthink. Domain in the math world is the set of all x coordinates on a graph written from least to greatest, all the x's that work. Now, I had a student a couple years ago ask me, well, doesn't that just mean how far left and how far right? And I said, yes, that's basically the idea of it. We do want to add a new question for next year, but really that is the summation of what's going on. Okay, we do have a third question we do want to ask ourselves is, are there any breaks? But that's not a question you'll ask yourself this year. Okay, for this year, it really is just these first two questions. How far left does my graph go? How far right does my graph go? Similarly, range is the set of y coordinates. So this is important because this is one of the two times we're going to care about this. Okay, usually we're looking at the x's. We saw last time when we were looking at intervals, we cared about the x's. We're going to see that today with increasing and decreasing. We're only caring about the x's. This is one of the few times that we really care about the y's. But the idea here is how far down, write that nicely, and how far up. Okay, again, asking that question, are there any breaks? But that's a question that you'll be more asking for next year. Okay, so let's go find these domains and ranges for these problems. I will go ahead and tell you this year, if you have to make a guess on domain, it's negative infinity to infinity. Because most students go, okay, I'm okay with the fact that this thing goes up forever on both ends. But they struggle sometimes with the idea that it goes left forever as well. Because this thing never stops going left. It's just going left slower than it's going up. But it never stops going left to negative infinity. It never stops going right to positive infinity. And again, if you had to make a guess, that would be your guess. Okay, looking at our next one. Range. How far down does this thing go? Well, the lowest it ever gets to is -4. And then the highest it ever gets to is infinity. Well, infinity always gets a parentheses. Now we have to ask ourselves, though, for that -4, do I want to include it? And up until this point, you've seen on pretty much every graph you've worked with that we've done parentheses for pretty much everything. But if I think about this for a second, this graph comes down, it gets to -4, it actually touches it, and then it starts going up again. Meaning, I do want to include it. So I'm going to put a bracket here. I'll go ahead and tell you for domain and range, it is more common to see brackets here than probably on anything else we do. And this year, other than the infinities, really it is going to be a bracket. Okay, next year you will have some cases where it is parentheses, but this year it really should be brackets on those. Okay, for this one, we can put some arrows here just to remind us that it doesn't stop going. Negative infinity, positive infinity. Okay, and then it never stops going down. It never stops going up. So here's where I see some students struggle sometimes. With the range, it's how far does it ever go? The absolute lowest this thing goes to is negative infinity. And what I see sometimes is students go up, 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 and they go, oh, okay, well, it only goes up to 3. Well, it does go to 3, but it doesn't stop there. It goes down for a little bit again, and then it keeps going up forever. And because it keeps going up forever, it does go from negative infinity to positive infinity. So it's just something to watch out for on those. Yeah, we can have a lot of repeat in the middle here, okay, and that's fine. But what is the absolute lowest it goes? What is the absolute highest it goes? And are there any numbers missing? Okay, and for this year, it really shouldn't be numbers missing. Okay, continuing on. Now again, like we said last time, square root here is the oddball. It's going to cause us problems in everything we do today. It's going to be very different. Okay, well, the farthest this thing ever goes left is -4. And then it goes right out to infinity. And it does touch -4, so we're going to put a bracket. Okay, the lowest this thing ever goes to is 0. And then the highest it ever goes to is also positive infinity. Yes, it's going right very, very quickly, but it never stops going up. And then since it does start at 0, we're going to give it a bracket. Okay, last one here. Again, let's put some arrows here just to remind us that it never stops going. So negative infinity, because it's never going to stop going left. It's going down very, very fast, but it never stops going left. And then positive infinity. Okay. And again, most students here go, okay, yeah, it goes down to negative infinity for the range. And then the highest it ever gets to is about 2.25. Okay. Just as a heads up, as long as you're close on those, it's going to be fine. Okay. I'm not going to ding you for saying 2.25 when really it's 2.2 or something like that. Okay. If I give you points there, then yes, I would like you to use those. But as long as you're close, I'm going to be happy. Okay. So that's domain and range. Again, please don't overthink domain and range. Domain and range is one of those topics that students just always want to overthink. Okay. Relative maximum. Now, the important word here is relative. There are 2 types of maximums, a relative one and an absolute. Absolute is the highest that graph ever goes to. Okay, we're not going to look at those this year, and you may not even look at those next year. And honestly, quite frankly, they're just not interesting. It's the relative ones that are nice, that are interesting. Okay, there can be more than one, and they are written as points. Okay, X, Y. A relative maximum has to have an increasing section and then a decreasing section, something like this or this. Okay, these are my hills or my humps. Conversely, a relative minimum, same idea. There can be more than one. These are also written as points. X, Y. And there are valleys, so they come from an decreasing section to an increasing section. It can be a sharp turn like that. Okay, so valleys. It must have both sides. Okay, it can't just begin and start going and be a minimum. So, how do we find these? Okay, let me clean up this graph just a little bit because we got some extra stuff there that happened that I don't like. There we go. Okay, so minimum here. I do have a minimum. It's right here. Okay, at 1, -4. Okay, and I don't have a relative maximum, so I'm going to put none or does not exist here. Okay, I do have those absolute maximums at infinity, but again, those aren't interesting to us. It's these relative ones. Okay, again, notice how it goes from decreasing to increasing. Okay, continuing on. I've got a minimum on this one as well. Okay, let's just make our numbers nice here. Let's call that 2.5 -3. And then I've got a relative maximum here. Again, let's make our numbers nice. Let's call it -2.5 +3. Okay, now something you're going to notice here is we have additive inverses. If we remember back to our last one, this one had odd symmetry. Okay, if we do have odd symmetry, this will always happen. Okay, continuing on. Now, again, square root's the weirdo. Most students are okay going, okay, this thing never has a maximum. It never goes from an increasing to a decreasing section. So most students go, okay, no maximum. But where we struggle sometimes on this is, do I constitute this as a relative minimum? And the answer is no. Again, I don't have that valley. I don't have that sharp valley. And because I don't have that, I don't have a relative minimum. I have what we call an absolute minimum, which in this case is somewhat interesting. Okay, but I don't have the relative, meaning none. Okay. Okay, minimum right here, 0, -4. Okay, that one was easy. Maximums here and here. And again, I'm just going to try to make these numbers a little nice. We're going to say -3, and then we said 2.25 was the highest that we went to. So let's keep doing that. And then here is going to be 3, 2.25. Okay, and again, noticing here we do have a pattern here as well. This is how we designate, even symmetry. Because remember, this one was even symmetrical. Okay, so again, minimum and maximums, not too bad. You've probably done them in the past, maybe don't remember them, but they're not too bad. Okay, now increasing intervals. So we're going to use that interval notation again. We're going to use those x values again. And it's when the function is going up. Okay, the minimum and maximum help find these, okay, but it's not an end-all be-all, especially with that square root guy. Okay, same idea with decreasing. X values on an interval. Okay, and again, those minimum and maximums are going to help us. So the neat thing is what we did last time is going to help us here, except remember last time we did that number line up top? Here we're just going to go to the bottom. So from every minimum and maximum, and there's one extra thing we have to do on the square root, but from every minimum and maximum, I'm going to draw a line down. I'm going to create a number line, okay, and then I'm going to write the x value. So in this case, 1. Okay, on this left side here, I am decreasing. And on this right side, I am increasing. It's going down, and it's decreasing, it's going up, it's increasing. So, decreasing, increasing, negative to positive. So from negative infinity to 1, I'm decreasing. Okay, now we have to decide what's happening right here. What is happening at this one spot here? Okay, well, the way to think about it is if I've got a skateboard, okay, and I've got a ramp. So I've got a skateboard here. It's going down, it's going down, it's going down, it's going down. And then at the very bottom here, the skateboard is going to flatten out. Okay, and then once I get past that point, it starts going up, and I can see the direction the skateboard is going, right? But at the very bottom there, it's flat. It's not going up, it's not going down. So similar to how these zeros were bad areas, this is also going to be kind of one of those areas where nothing's really happening. So it's going to be parentheses. Okay. And then from 1 to infinity, I'm increasing. Okay. And for all the same reason, I'm going to use parentheses. Okay. Same idea. Okay. Let me erase this odd symmetry down here. I'm going to draw lines coming down from my maximum. I'm going to draw a line coming down from my minimum. Create a number line from negative 2.5 to positive 2.5. And we did try to keep these numbers a little nicer in your homework, but there are a couple that are kind of in the middle, so just make a good guess. Okay. When I do my highlighting here, I have an increasing section here. I've got an increasing section here. I've got a decreasing section here. Okay, so increasing from negative infinity to negative 2.5, decreasing in the middle, increasing on the end. So increasing, negative infinity, negative 2.5, decreasing, negative 2.5 to 2.5, and then increasing again from positive 2.5 to infinity. Okay, and we're going to use that union symbol because we've got intervals. Okay, so again, square root is just going to be that oddball for us. Okay, most students are okay with the idea that this thing never decreases. Okay, great, none. So we go, okay, so we've only got an increasing section here. Oops, we make that blue so it matches what we've been doing. Okay, so we've got that increasing section. What I'm going to do is I'm going to take this tail here. Okay, and I'm going to say -4 here. Okay, well, over here, my function does not exist. Okay, and over here, it's increasing. But at -4, it hasn't started doing anything yet. And because it hasn't started doing anything right when it started, existing, we're going to say, okay, well, unfortunately, it's not increasing yet. It's not until that very next spot that it starts. So -4 to infinity with parentheses. And in fact, in math, I can't think of a single time when we would use a bracket for these. Okay, so we really do want to be using parentheses for all of these. Okay, last section. Let me get rid of that even there. I'm going to draw those lines coming down. I'm just going to do them on the 3s there just to make my life a little easier. Okay, remember it's not off the y-intercept here that I'm doing it. It's off the minimum there. Okay, so we're going to say -3, 0, 3, negative infinity, positive infinity. Okay, over here, or actually let's do the highlights. Let's not skip steps. So increasing, decreasing, decreasing. Okay, so then increasing, decreasing, increasing, decreasing. So from negative infinity to -3, I'm increasing. From -3 to 0, I'm decreasing. From 0 to 3, increasing again. And from 3 to infinity, decreasing with some unions. Okay, sorry. Again, I know this video is a little bit longer, but we got 7 things to cover this time instead of just the 5. Okay, now, this last one, end behavior. End behavior is one of those things. There's 2 good ways to teach it, and we're going to be doing it the way that is expected at West Jordan. So just to make sure we are doing the same thing with all the other classes, help prepare you for next year, so your teachers you're coming into those teachers, we're going to do it all the same way. Excuse me. So that being said, we're going to use what we call the limit notation. So the limit notation says limit of my function as x approaches negative infinity, okay, equals something. Okay, what this thing means, this whole thing here, what it means is going left. Where does my function go? Okay, now for this year, I will go ahead and tell you it's going to be one of 3 answers: negative infinity, infinity, or does not exist. Those are your only 3 choices for this year. Next year, you're going to find that we can go to other things, but for this year, it's one of those 3 things. Okay, well, this is the left side. We have a right side as well. So this part of our problem will always have 2 answers. So the limit as we go to infinity of my function equals blah. Okay, and again, this just means going right. Where? Okay, so on these, best thing to do is just go ahead and go write the limit behavior, and the limit definition. So limit as x approaches negative infinity of my function equals, okay, so as I'm going left, I'm going up. So the way I like to do this, I like to put arrows on the thing. As I go left, I am going up. So as I go to negative infinity, I'm going to positive infinity. So there's my answer. Okay, and then for the other side, the limit as x approaches positive infinity of my function. So as I go right, I go up to positive infinity. Okay, so the hardest part about this is just getting the notation to look right. Other than that, the idea is pretty simple. I go left, I'm going up. I go left, I'm going up. Or right, I'm going up. Okay, where am I going? So limit as x goes left to negative infinity of my function. Okay, so as I go left, I'm going down to negative infinity. And then right side. Okay, so as I go right, I'm going up to positive infinity. Okay, now again, unfortunately, square root's the oddball here, because if I think about this, so again, remember the idea is as I go to negative infinity. Well, does this thing go to negative infinity? And the answer is no. So does not exist. Okay, but it does have a right side, because as I go right, I do go up forever. Okay, so limit as x approaches positive infinity of my function does go up to positive infinity. Okay, one more and then we're good. Okay, so limit as x goes to negative infinity of my function. So as I go left, I go down, so negative infinity. And then limit as I go right of my function. So as I go right, oops, stop that. Nope, undo. Get that pen back. As I go right, I go down to negative infinity. Okay, so that's it for today.